Hello everyone and welcome to my first PostgreSQL Quickie. You might ask now, what is a PostgreSQL Quickie? Well, if you already know me, you know my famous SQL Server Quickies. The goal of my SQL Server Quickies is to show you concepts in SQL Server just within a few minutes. And over the last 2 years, I have also concentrated more and more on Postgres, and now I want to transition the concept of the SQL Server Quickies just over to Postgres. Means I want to show you in a Postgres Quickie just one specific feature or concept around Postgres. And today I want to start just by talking how easy it is to run Postgres in combination with Docker containers. Before we dig into the details of Postgres, I just want to briefly describe what Postgres actually is. Postgres is just a relational database as SQL Server. But the biggest differences between Postgres and SQL Server is just the fact that Postgres is entirely an open source project. Means you can look into the source code of Postgres, which is available on GitHub, and you are able to dig into the internals of Postgres. This is really powerful in comparison to SQL Server, because as we know, SQL Server is just a closed source product offered by Microsoft. Another key difference between Postgres and SQL Server is also the licensing model. In SQL Server, we have different editions like the Standard Edition, the Enterprise Edition, which is very expensive. On the other hand, Postgres is completely free. Means you just download Postgres, you install Postgres, you run it, and you don't have to pay anything. It means all the features that Postgres offers you doesn't cost you anything. It means you can create fully high availability solutions with Postgres, where you can read from secondary replicas like in SQL Server with SQL Server availability groups, but with Postgres you are not paying anything. Postgres is completely free and open source. So this is a huge difference and a killer feature in comparison to SQL Server. The first initial release of Postgres was done in the year 1989. It's already a very long time ago. Back in that year, I was just 9 years old. Means Postgres has a really long history. And back in these days, Postgres was just called Postgres because it was a successor to the Ingress database system. Therefore also the name Postgres. Prior to Postgres there was Ingress, and after Ingress comes Postgres. So that's the idea of the name Postgres. So this is also interesting to remember and interesting to know. And in the year 1996, Postgres was renamed to PostgreSQL because it incorporated all the famous SQL features, so from the programming language that we already know from SQL Server. When we install today Postgres in a Docker container, we will see that the latest version of Postgres is 17.6, and it's also important to know that the goal of Postgres is to ship a major version every year. Currently there's already a release candidate available for Postgres 18, which will be shipped over the next months. So let's switch now to Docker and let's have a look how easy it is to install and run Postgres in a Docker container. So let's deploy now Postgres with a Docker container. First of all, we need a Docker image of Postgres. We can use here the docker bull command, and we are just bulling the latest Postgres image. As I've said previously, that latest image of Postgres is the version 17.6. So let's do that. As you can see, I have already the latest image there, because I have done that previously. And now when we do a docker image ls command, you can see the image is there. It's the latest one. And I have also, for example, here another image for SQL Server 2022, which is also the latest one. Let's do now in that image Postgres latest a docker inspect command. Means with a docker inspect command you can just inspect that image, for example, to find out which version of Postgres is running in that image. And as you can see, we have here a BG major version of 17 and the specific detailed version is 17.6-1. So this is just the latest stable released version of Postgres. In the next step, we need now to spin up a new Docker container from that image. You can think about a Docker image like a traditional ISO image of a software package that you have downloaded from the internet. Means you also have to install that ISO image. And we are doing here the same with a Docker image. So we can run now that image that we have pulled previously with the docker run command. Means we give that Docker container that we're spinning up a name. In our case, let's just call that Docker container Postgres. We have to pass in some environment variables. Means when we spin up that Docker container, Postgres has a standard user called Postgres. And that standard user needs a password. And we are specifying that password here. You can think about that Postgres user as the SA user in the SQL Server world. When you're spinning up a Docker container for SQL Server, you also have to specify the SA password through an environment variable. And we're doing here the same with the Postgres image. And then we just do a port mapping, means Postgres is running always by default on the port 5432. SQL Server, as we know, is always listening by default on the port 1433. And we just take that port 5432 and map that port from the Docker container to our host system, to localhost. Means when we run now that Docker container, the Postgres installation will be available on localhost on port 5432. We run the Docker container in the detached state, means it just runs in the background, and we are using the Postgres latest image that we have pulled previously. Let's do that. As you can see, we get here hash value, and that hash value is just an identifier of the running Docker container in the background. We can also verify if the Docker container is running with the docker ps command -a, and as you can see, we have here now one Docker container that is running. You can see which image you are using, the Postgres latest one. You can see the Docker command. You can see when you have created that Docker container, how long it is already up and running. You can see the port mapping as I have described previously, and you can also see the name that we have specified. When you have now the Docker container up and running, the next question is now, which tool do you use to access the Postgres installation? As we know from SQL Server, we have SQL Server Management Studio, but on Postgres there are different ways. In the past, I have used a lot Azure Data Studio to work with Postgres, but the problem is that Microsoft has just deprecated that tool because Microsoft provides us an extension for the Visual Studio Code Editor. The problem with the current state of that extension is that doesn't support that much functionality, so currently I don't really recommend to use VS Code to access your Postgres installation. Another tool that you can use, which is also completely free, is TPeber. You can download that for free. There's a community edition available, and that tool doesn't cost you anything. And this is for me currently the preferred way to work with Postgres. As you can see, I have here already a database connection prepared. Let's have a look on that one. So as you can see, more or less we're doing here the same as when you're connecting to a SQL Server instance. You specify your host. In my case it's localhost, because we have done the port mapping. You specify the port 5432. You specify the database to which you want to connect initially. There's always a database Postgres available. Think about that database like the master database in SQL Server, and then we just specify the other authentication. In our case, I specify the Postgres user and the password that we have specified previously during the docker run command with the environment variable. So let's connect here. As you can see, we have connected, and now you can see there's a database Postgres. Think about that database like the master database in SQL Server. The Postgres database is always there. There are also other system databases that Postgres is using internally in the background. We will also talk about them in a subsequent Postgres Quickie. In the next step, let's create a new SQL script. I've already prepared here some code. First of all, I just want to show you how you can create a database. It's quite simple. More or less we're doing the same as in SQL Server. We just do a create database command and we specify the name of our database. One very important thing here is there is no Go batch separator that you know from SQL Server Management Studio. In Postgres there is no way to execute a Go, but you have to end every command with a semicolon. So this is very important. In SQL Server there are some commands that must be terminated with a semicolon. In Postgres every command must be terminated by a semicolon. So this is the first very important point to remember when you are migrating from SQL Server to Postgres. So let's run that command. So as you can see, you can do here an execute SQL query, or you press Ctrl Enter on Windows. Let's do that. So we have created that database. Let's do here a refresh, and as you can see, our new database is there. The question is now, how can you switch into that database? As you can see, we are currently attached to the Postgres database, and inside that Postgres database to the public schema. In Postgres there's no use command so that you can switch database context. This is also very important in Postgres. When you have a client connection, that client connection is always tied to one specific database. If you want to switch to a different database, you need a new client connection. We will also talk about that one at a later Postgres Quickie, because Postgres is using a completely different process model as we know from SQL Server. The easiest way to switch the database context here in TPeber is just to set your default database. So let's do that, and as you can see, we are now in the database test in the schema public. Let's create a new table here. I call that table test. I have just two columns, integer column 4 bytes long and a fixed length character columns which can store up to 100 characters. When we look into our public schema, you can also see we have that table there. Let's insert two rows. So I'm inserting myself and my wife. Quite simple. When we do a select star from that table, you can see that both records are there. As we know, we are working here currently with a Docker container. When you are working with a Docker container, it's also very important to know that your data is persisted across restarts of your Docker container. You are only losing the data when you remove the Docker container. You could also prevent that by using so-called Docker volumes, but just to make it sure, by default, when you stop and start a Docker container, you're not losing any data. Let's have a look on that one. So what we are doing now, I'm stopping that Docker container with the docker stop command. Let's do that. We can again verify that, and as you can see, the status of our Docker container is exited. Means when we do here a refresh again, we have an error. Makes sense because Postgres is just shut down, means nobody is currently listening on board 5432. Makes sense. Let's start that Docker container again. So let's start Postgres. Let's verify it. As we can see, the container is again up and running. And let's do here again a refresh. As you can see, we have again connected. And guess what? Our database is still there. So this is also very important. You're not losing any data, because a lot of people are always telling me, yeah, Docker, this is not so good because your data is not persisted. That's not true. The data is persisted across restarts of your Docker containers. You're only losing the data when you're stopping and removing your Docker container and when you don't use Docker volumes. Means in our case, when we do now a docker stop command and afterwards we do a docker remove command with the name of the container, now we have lost everything. Means the table test with the two inserted records, because as you can see from the docker ps command, the Docker container is just gone. It's not there anymore. Of course, the image that we have pulled previously, the image is still there. As I've said, just think about a Docker image like an ISO image that you have traditionally downloaded for a software package from the internet. In this first Postgres Quickie, I gave you a short introduction and a short overview about Postgres, and then you have seen how easy it is to spin up a Docker container and run Postgres with it. I have spent the last 2 years a lot of time working with Postgres because some of my customers have migrated to Postgres, because these days Postgres is a really strong alternative database to SQL Server. If you're interested in how to transition your existing SQL Server knowledge to Postgres, I will run by the end of November a live online training about that topic, and please make sure to check out the link, and I'm already looking forward to see some of you in that training. So thanks for watching my first Postgres Quickie, and I'm already looking forward to the next one, which I will release over the next time. So thanks and enjoy your work with Postgres. Thank you.